Okay, for number 5, we have a circle, and its circle is centered at 0, 2. It has a radius of 2. I'm going to visualize this on the whiteboard later. And then it says circle C2 has a center 2, 0 with a radius of 2. So these are two circles of the same size, but they have different centers. So what I want to do is I want to visualize this. Problem number 5, and we're going to visualize number 5. So the first thing, again, going back to the original wording of the problem, and we have a circle, C1, that's centered at 0, 2. So go up 2, 1, 2, that's the center, and the radius is 2. So it looks like a pretty easy circle to graph out, by the way. And I'm just going to, put the 4 points down. And this point's pretty easy, it's just 0, 0. This point over here is going to be, let's see, 2, 2. This point over here is going to be 0, 4. And this point over here is going to be minus 2, 2. And we got a circle there. Looks like this over here. And again, it isn't like drawn perfectly, just enough idea that you read it and you understand what that circle is. But there is another circle. Another circle has a center at 2, 0. So its center is over here. That's the center. And it has a radius of 2. So I got a point here, got a point here, got a point here, and a point over here. Let me just draw that in. All right, let's just put the points down. And there's 2 points I don't know yet. But it's really easy to do. It's really nice, easy circles. 4, 0. This one's going to be 2. And we're going down by 2, minus 2. Now, what's their question? The circles overlap in the first quadrant. I do see that. It overlaps here. All right. What is the area of this overlap? The way I would do it, again, we try to do the simplest possible way. I mean, someone said I want to do the integration. You could do that. But I think the simplest possible way is just to recognize that I've got a square here. All right, that's a square. What's the area of the square over here? I'll put area square down. The area of the square, well, it's just a 2 by 2 is 4. Now, by the way, I'm also seeing a sector. And really what that sector is, this is the sector now. So the area of a sector, all right? So this is area square, SQ, I'll put over here. The area of the sector, I'll just say sector 1, by the way. What's that going to be? Well, it's 1/4 of the area of the circle. So it's 1/4 pi. What's the r? The r is 2. So r squared would be 4. So the area of the sector is pi. Right? By the way, I got another sector. Like if I looked at the other thing, I'm looking at this thing over here. I got a sector like this, which is really an identical sector. I'm going to say area of sector 2. So what does that give you? It gives you 1/4 pi times r squared, which is 4. It still gives you pi. All right. So the problem I have now is figuring out what they want. What I'm doing if I added those two sectors together, I'd have I would count these things twice. By the way, these sections be counted twice. By the way, and so what I'm going to do is I'll take I'll add those two sectors together, pi plus pi. And then I know I'm counting two of those things, but I got to remove this over here. So I'm just going to remove the full square. So minus 4. What would that remain? Well, remember, this includes 2 of the sectors. That includes 1. So when I say, I'm sorry, I shouldn't say sectors, that overlap. This includes 2 of the overlaps. This is 1 of the overlaps. 2 minus 1 would be 1 of those things. What does it give you? 2 pi minus 4 would be the area of the overlap. So 2 pi minus 4. And we're done. Thank you.